Sweet. All right, so polymorphism. I just chose that one word for this slide title because it was just a great word. So what are we learning today? Interfaces, polymorphism, and by nature of talking about polymorphism, we're going to revisit casting, which we talked about last class. The image on the right is something kind of interesting. So I fed the one word polymorphism into Stable Diffusion. Tried it a couple times, and that's the most interesting thing that came out. It almost looks like a combination of like, what do you call those things in the sky where people like make shapes out of them? They have like names, constellations, or like ancient stone art. So definitions. An interface, it's not technically a class. An interface is like a class, but it can only define methods and do nothing else. So it's way more limited than an abstract class. Polymorphism is not a piece of syntax, it's not like a logical thing inside of Java, it's rather a concept. And so the concept of polymorphism is essentially saying that classes are able to morph into parent classes or interfaces that they implement. And so an example of that would be taking a car or a boat or a plane and treating them all as a vehicle. That would be polymorphism. So you have one class morphing into this other class or other interface that is a part of. So interfaces. Here's a code example. So we have an interface. We have an interface called shape. And we only have one method defined inside of our interface. And that method is getArea. It's defined as a public with a return type of double. And so here is a class. Now notice that this class implements the interface. This is different than, let's say, if we were to extend an abstract class or extend a regular class, we'd use the term extend. In this case, we're implementing the interface. And the way we implement an interface is we essentially write the method that was sort of outlined here. So this interface is basically saying, if you're going to implement this interface, you have to write a method like this. And so here we implement it, we write getArea, and essentially getArea returns length times width. The other parts of this class are grayed out because they're not relevant to this specific example. So to compare abstract classes with interfaces, they're really quite different. So like mentioned earlier, we extend classes, but we implement interfaces. We could hypothetically extend a class and implement an interface all in the same place. So abstract classes can have methods, they can have fields, they can have private fields and methods, and everything basically that a regular class can do, an abstract class can do, with the exception that you can't just create an object out of an abstract class. You have to extend it. On the other hand, for interfaces, we can have methods in the sense that we can define methods, but we're not actually writing the rest of the code. We're not implementing the method. We cannot have any fields with the exception, with the caveat of constants. So with an interface, we can have a constant field, which is a static final field. And interfaces can't have private methods because there's not a good way to implement that. So you may hear of interfaces referred to as contracts. The reason why they are referred to as contracts is essentially whatever you put in your interface, Java is going to enforce that you implement it. So if you had an interface with 3 methods defined in it, and you implemented 2 of the 3 methods, Java won't compile. It'll get angry. It'll yell at you saying like, hey, you did not fulfill the contract of the interface. So cool. So we're going to look at some code in IntelliJ and mess around with interfaces. Before I do, pause for questions. Thoughts, questions, anything? Cool. All right, let's jump. Yes, sorry.
Someone's saying, I'm writing contracts. Is this what they're referring to?
If someone says, I'm writing contracts, is this what they're referring to?
It's all for
I'm not aware of like writing interfaces being called writing contracts. Maybe some people call it that, I'm not sure. I am aware that people will describe an interface as a contract. So like when they're trying to explain what it is, they'll describe it like a contract. But I haven't heard people like in the development space saying like, I'm going to write a contract. They'll probably just say I'm going to write an interface and assume the meaning transfers. Yeah. So, but I mean, I'm sure I'm sure people call different things. Right. Gotcha. Cool. Other questions? No? Let's jump over to IntelliJ. I always forget the shortcut for zooming. I think I'm trying it. Does someone remember the shortcut for zooming? Control Shift period. Or Alt Shift period. There we go. Sweet. I was doing like every combination of Control Alt and Shift with the plus sign because that's most everything else, but not IntelliJ. All right, cool. So in this example, we have a we're just looking at this file right here. We have our main class where we're just going to run the code. And outside of our main class, we have a vehicle interface. And this vehicle interface basically says, if you're going to implement me, the vehicle interface, you have to have a start method, you have to have a stop method, you have to have an accelerate method, and you have to have a brake method. So if you're going to call yourself a vehicle, you got to implement all these things. Here we have a boat class that implements vehicle. It already does all these things. We won't really spend too much time looking at this because we're going to write some code. And here we have a car class that hasn't really been finished yet. Looking back at our main class, we can see we created a new boat. We're technically upcasting it to vehicle. There's not really a good reason to. But since all of the methods that we're using are part of the vehicle interface, we're not breaking anything by upcasting it to vehicle. So if I run the code, make sure I'm running the right one. Yeah, that's the right one. If I run the project, it prints out starting engine, and then it says engine's running, and then it says accelerated to 2.1 miles per hour. Cool. So let's jump over to our car class. Our goal now is to implement the vehicle interface. And the first thing that happens is Java gets mad at me. And I feel like it's maybe jumping the gun on this because I'm just trying to implement this interface. But it's essentially saying that we have, we're implementing this interface, but we haven't actually satisfied the requirements. So an easy way to do this is to go to generate. And I'm going to click on implement methods. And from here, all of them are selected. I'm okay with that. Click OK. And so it just generated a bunch of empty methods. But these are all the things that the vehicle class requires. And so now that I have all of these empty methods, I'm just going to go ahead and fill them out. I'm going to keep it simple. Starting car. For this, stopping car. Okay, so for this one, we actually need to do something more than just printing something. So we will basically say, take the speed, say this dot speed, which doesn't exist yet, plus equals speed. Cool. So I know I need a speed field just because of the way this whole contract is set up. So I will say private double, call speed. Cool. So now we have speed, and then finally we'll say this dot speed equals 0. We could do something more creative and maybe like decrement the speed, but we're just going to say when we break it completely, or we break completely. Okay. I'll say right. And then the last thing we need, and it's not complaining about this, but we need a constructor. Cool, easy enough. Now let's see all of this work together. We'll create a new car, called car, and I'm actually going to change the constructor. I don't want to set the speed on when I create the car because it doesn't make sense for the car to be going 5 miles an hour when I initially create it. So instead, when we create the car, speed equals 0. And then here, car equals new car. And now I should be able to call all these methods on it as the same way I did for the boat. So for, I'll say car.start, car.accelerate, and we'll do 7 miles an hour. I have to do .0 because it's a double. If I don't have the .0, it thinks it's an integer. And I'll run this. It's thinking. Or is it? Oh, yeah, there we go. All right, cool. So for the boat, start the engine. Engine's running, accelerated to 2.1 miles per hour. For the car, so it started car, and then it accelerated up to 7 miles an hour. Cool. So that's sort of the example I want to share as far as implementing an interface that we created ourselves, a custom interface. Thoughts or questions after seeing the code? No? Okay. Hopefully it's yes.
You have to use override every time, right?
It's a good question. Let's see what happens if I try to remove it. So far, nothing red and angry. Let's run this again. And for whatever reason, this takes a long time to run. I'm not really sure why. It's there's not a lot of code to run. Wait. Yeah, so it looks like we don't need to explicitly say override. I feel like it's probably similar to a lot of the cases when we'll use like this dot speed is to be like explicit. And so in this example, we don't need to say this dot speed. We could just say speed. So I'm supposing when we had IntelliJ automatically generate these, it probably included override just to be explicit that this is overriding the like an inherited or an extended method. Yeah, cool, great question. Other thoughts or questions? No, all right. Cool. So polymorphism. Call this a deep dive, but I don't know how much time this will actually take. So a loose definition is essentially just classes morphing into parent classes or interfaces, and then vice versa. So this idea probably seems somewhat familiar based off the fact that we talked about casting last class, and casting is essentially like an actual practical implementation of the concept of polymorphism. So a few code examples for upcasting. Here we are upcasting the vehicles of car, boat, and plane. We upcast them when we add them to this array list of type vehicle. And so they're no longer casted to be a car, a boat, or a plane, but they've been upcasted when they've been added to the array list. And then we can do our for loop where we loop through each item. So another example of upcasting would be, let's see, this looks very similar. What did I change? I changed nothing. This is not another example of upcasting. Another example of upcasting would be explicitly upcasting them like after they've been created. So we could say something like, we're going to create a vehicle, type vehicle object, and we're going to take my car and upcast it to vehicle. This is very similar to what the syntax looks like for downcasting. And then lastly, a way we could see upcasting is when we initially create it, we say, this is type vehicle, even though it's a car. And then here's our example for downcasting. For downcasting, we want to be careful that we don't assume that the thing that we're trying to downcast is in fact what we're trying to downcast it to. Because if we try to downcast something to a class that it's not, it will crash the program. And so here we carefully check if it is in fact an instance of car before we downcast it to car. A note on upcasting, when we upcast, we only have access to the methods of the upcasted type. So if car has a method that vehicle doesn't have, then we can't access car's unique method. We can only access the methods in vehicle. Interestingly enough, if car overrides a method in vehicle, when we call that method, we will use the overridden method in car. And so you can almost think of it like how interfaces work, where you're essentially just accessing the methods, but the actual implementation of it is handled by the class. So polymorphism allows our code to be more flexible. So if objects share a common parent, class, or interface, we can use the flexibility of polymorphism to apply the same logic to all the related classes. That's what makes it useful, etc. Then we have an example down here, which I don't know if I need to go into. So pausing here before we change gears, thoughts or questions on polymorphism, upcasting, downcasting, anything in between? Yes?
How often is polymorphism
It's a good question. I would say it's probably used quite frequently, and probably it's not always realized when it's used. So as far as how often is polymorphism used for a custom class, let's say I was a developer and I made this custom vehicle class, I think it would be pretty much up to me as a developer how often I use polymorphism. I'm not really sure the best way to answer that question, but I would assume that it's going to be a natural part of coding in Java, because if you ever ran into a situation where, let's say hypothetically, you had a website with 3 different types of users. You had like an admin, you had like a team lead, and then you had like a regular user. Let's say those were all their own classes. But now let's say you wanted to run a process regardless of what role they had. Using polymorphism is going to be perfect in that scenario. So you can just treat everyone as like a generic user, regardless of what their special class is. So I would imagine that probably get away without using it, but it would just come up naturally. Yeah, cool. Thanks for the question. Cool. Other questions? All right, moving on. So I wanted to put in something here about graded assignment. This is a sort of a small thing. So something that I noticed in graded assignment 2 is that something comes up where it asks us to call like a blank default constructor. And so in Java, we might have a block of code in our default constructor doing things like adding a created date, setting the ID, etc. And so we might want to call the empty constructor. So let's look at this code example real quick. We have pretty much some pretty standard fields that we'll see in a lot of cases. We have an ID, and we have a name, and then we have this special little static field which helps us iterate the ID. So I have an empty constructor that sets the ID on its own. But if I don't want to like copy and paste this code for all of my other constructors, how can I call the empty constructor here, right on this line right here? So that's a question. Would anyone like to take a go at answering? Yes.
Use this and then parentheses.
Yes, use this in parentheses. And so this is how we can call the default constructor right here. Then we can avoid having to copy and paste that code. And hypothetically, our default constructor could get quite complex, especially if it was setting like the like a bunch of date fields and like the ID field and different like relationships. And so it could be very helpful just to be able to call a specific constructor this way. So yeah, that's just a quick tip for something that I think comes up in a graded assignment 2. So as a recap, interfaces, they're similar to abstract classes, but much more limited. An interface, I called it a class, but I know it's not a class. An interface is something that can only define methods and nothing else. The exception we talked about is that it can have constant fields. And then polymorphism, classes are essentially classes just being treated as like the parent class, and basically being able to have the flexibility to take classes and treat them all the same at like a certain level. If you like climb up a step, to the parent class with parent interface, we're able to treat multiple, I guess, sibling classes like the same way. Cool. So I wanted to review the exercise because it does something really cool here, implementing a built-in Java interface. I'm going to go ahead and delete these. Okay, let's see here. Getting us back to baseline. Right, so let me pull up the directions. Cool, so with this exercise, hopefully you've already done it, this is just a review, but with this exercise, what we're doing is we are creating a special class that will be used to sort our custom class. So the directions are to create a public class called Flavor Comparator. So we'll do new Java class Flavor Comparator. Cool. And then jump back here. And so we're going to have it implement comparator. I'll just copy this. And so this right here is a built-in Java interface. Alt-Enter. There we go. And I don't know if I mentioned this, but you can actually implement multiple Java interfaces, or just multiple interfaces, period. But you could only extend one class. So just an FYI. All right, let's see here. Jump back to the instructions. Right, so it's complaining at us, just like the example we saw a minute ago, where we're implementing an interface, but we haven't met the requirements of the contract in that the interface has a required method. So we'll go generate, implement methods. We're going to do this one right here, compare. And so this one right here, it's not doing anything yet, but it's taking in flavor A and flavor B, and then we're going to need to write some code that actually compares them. Now, the way these compare methods work, you might think it would be something like, if they match, it's true. If they don't match, it's false. But it's a little bit more nuanced than that. So it's something like, if A is greater than B, that's a 1. If A is less than B, that's a -1. If A equals B, that's a 0. And so we need a case for A is greater than B, A is less than B, or A equals B. And so that's 3 different possible outcomes. And because there's 3 different possible outcomes, we're not going to use like a true or false output. Instead, we're going to use like a 1, 0, -1 pattern. And you will see this come up in other examples in programming. I've definitely run across these examples before. I'm like, oh, I'm just going to change this to true or false. And then I realize, well, there's actually 3 options. Right, and so they give us the code, nice and easy. And we don't really get to see the logic because we're just using the built-in compare to method that Java gives us. And so now we have our flavor comparator complete. And so now it wants us to create a new comparator. Just copy it from here, be super easy. Just gonna ignore the to-dos. Right, so here we create a new instance of this comparator class that we just made, the flavor comparator. And now we are going to sort the array list of flavors using this special comparator. And what happens later on is that it will ask us in the exercise that it wants us to print every item in the array. I kind of want to do that now so we can actually see that what we did worked. So we'll say for we will do this, and then let's click this button to update our thing up here. We'll run it. My laptop's taking a while, but we got it. Okay, so it goes in alphabetical order, and so that's great. If we were to comment out this sort, it's not going to be in alphabetical order anymore. Whenever. All right, cool. Right, so we can see here that our custom sort method is working. What happens if we call sort on it without the comparator? It gives us an error because it's asking for us to pass in a comparator. Cool. There we go. So the next thing that we need to do is we need to sort the cones by cost. Now, by cost, that's going to bring in that whole paradigm of like the 1, 0, -1 thing that I talked about earlier. So let's go ahead and do that because that'll be interesting to see. Cone comparator. Let's create it. Not comparable. Comparator. We'll do cone. That looks good. And then we need to implement the method. No. We need to implement the method required by the contract. So we'll go to generate. Then we will go to implement methods. And we'll do compare. Okay. And so here is where we need our a bit more custom logic. So I also don't like this 0102. I'm going to say cone 1 and cone 2. So I'll say something like if cone 1 minus, or we'll just say is less than cone 2. I'm just going to guess on like which is correct. It's either going to be sorted in the right direction or the wrong direction. But I'll say return -1, else if, and then I'm going to take this logic right here. I think it wants types, does it? Oh, I need to do dot get cost. Cool. Then we're going to return negative. We're going to return just 1. And then if it is neither of those, we will return 0. We don't need an else statement because just how the return statements will exit the code. All right, let's test this out, see if I got my logic right. I don't? Oh, someone's flagging me down. All right, so I need to switch them? Oh, thank you, they're right here. I appreciate the help. All right, let's go over to main. And gotta rename things. No, this is... And then we will say cones dot sort. We'll add in our comparator, cone comparator, check. And then here we will say, instead of that, it was probably easier just to type this out instead of copy it, but that's okay. Cone of cones. We'll say cone dot. Let's do this. Let's add on some stuff to this. Cool, let's see what this gives us. So this should sort from least to greatest, I believe. Right, so it looks like we're successful. We have apple at 5 cents, wafer at 50 cents, sugar at 75, and then waffle at 125. Cool, so success. We made it through at least up to the bonus mission for the exercise. After seeing that, were there any questions on what we went through? Anything that stuck out to you? Curious. Yes.
So this is just my understanding of upcasting. If we had stored every ingredient into an array list of ingredients, so like we upcasted all the flavors and all the cones into one single array list instead of two array lists there, we call it an array list of ingredients. Okay.
Okay.
If I was going to iterate over that array list,
Mm-hmm.
I couldn't call, like say, cones didn't have I couldn't use a get price for the cone if that was only defined in the cones class. I would have to pull an object out of the array list, cast it down, and then use it.
Right. So if get cost, and let's just verify this real quick. If get cost existed. It looks like in this case, like everything is inside of ingredient. But if hypothetically, if get cost only existed in cone and not inside of ingredient, and our array list was of type ingredient, we couldn't call unless we downcasted it and like what you're describing. So yeah, like what you're saying makes sense to me. Yeah. Yep. Question?
Yeah, the if else loop where we have the three situations like -1, 1, and 0. Is that only going to be where we're handling the type of integer or number given elements?
Right. So the question was what we have going on here, where we are returning a -1, a 1, or a 0. Is that just for comparing number types? Was essentially the question, right? So the answer is actually no. So we don't see it happening. It's happening behind the scenes. But this compare to function is also returning a 1, a -1, or a 0. And then when we call sort, it's going to sort based off of 1, -1, 0. And so that's what sort's essentially going to expect. Yeah, it's just happening behind the scenes here, but whether we're sorting strings or anything else, yeah, that's how it would be.
I'm sorry, if the compare to function is -1, 1, and 0. Right?
Yeah, the compare, yeah. I'm sure, yeah, compare to is probably the same, yeah.
Does it work with doubles also, or just integers?
So this right here, so this would, if this were to be a double, I think it would break it. If I were to call this double, we could find out. Call this double. Does that matter? I don't know yet. We'll find out. My gut tells me it's going to break, but right, so it's not going to let us do a double. It's not even going to let us make that mistake because the interface says it has to be an integer. And so in that case, the interface is being strict, but helpful in that sense. Yeah. Cool. Great questions. Any other questions? Right. Okay. So we are definitely wrapping up early here. I do have a bit of an introduction for the studio. There we go. So here's just a quick visualization of what's going to happen in the studio. So essentially, you're going to, with a partner or as a group, however your TA structures it, you're going to define on paper or in your head or however an interface called optical disk. And then you're going to have an abstract class implement that interface. The abstract class is going to be called base disk. And then from there, you'll create a DVD class and a CD class that extend the abstract base disk class. And then once you have all those pieces together, that whole chain of interface, abstract class, and two classes, then in your main section where you run the code, you'll run an instance of your DVD and CD class and just sort of prove that it all works. So the majority of the studio is going to be just sort of thinking through what needs to be in each of these classes and then writing the class. There's not going to be a lot of like running it and seeing it print stuff. That's more at the end of it. Cool. So that's it from me. Go ahead and break into studio. And yeah, so I'll see you all back here at 8.